warning. The video you are going to watch now is part of a thesis and an essay. Almost nothing that will be said has the official signature of astronomical science. So, when it comes to new and purposeful ideas, you can include this video in the field of science fiction. The author. Einstein's theory of relativity predicts that time and space would be elastic and would form a continuum. That is, when one of them stretched, the other would contract. Likewise, if space were to contract, time would expand. One effect would complement the other. The approach, taken in images of the universe, tries to innovate a little, taking into account, differently from classical physics, that the observer's point of view could influence our evaluation of external events, attributing, for example, a secondary character to some forces, as is the case with gravity. For this, it is not necessary to act directly on a mentioned force, it just changes the point of view by which it is examined. This way of exposing the universe to the observer's eyes tends more towards a subjective evaluation and seems to have a philosophical content. The same observed event can have more than one interpretation. Normally, science avoids abstractions about the nature of reality, preferring to stick to the premise that only exists what can be measured directly. When Einstein referred to Newton's absolute space, in his book How I See the World, on page 168, he tried to justify his predecessor's view, even without agreeing with him. Einstein tells us that Newton's acceleration is only thinkable and intelligible as an acceleration in relation to the totality of space. This geometric reality of the concept of space is, therefore, associated with a new function of space, which determines inertia. Its effectiveness in determining inertia remains independent. The space acts on the masses, nothing acts on it. This way of thinking was soon abandoned by physicists because, in this case, space would act on the masses, and not the other way around, as is currently accepted. The model, proposed in images of the universe, suggests that the space-time continuum would be one of the indicators of the influence of the observer's memory on physical reality. This stems from our dependence on the constant presence of cosmic radiation, synthesized in the word light, to define changes in the geometry of space. The space would only curve if the light also bends, as we do not have another tool available to make this measurement. If the light were not available on Earth, where there is a conscious observer, the stars would not exist in practice, because they could not be seen. Then, this fusion between space and light, which would have resulted in the continuous space-time of relativity, would be determined by cosmic radiation, and not by space. The conception of science is that space, time and light could only be on the inside of the visible universe, because nothing would exist outside of it. This way of looking at things cannot be censored when we place ourselves in dependence on a messenger to describe the space itself, which would only be the center of the message. A very convincing example, which illustrates the real separation between light and space, and the veiled rupture of the continuum, is the concept of cone of light of the future of the Sun. If space and light formed a continuous whole, we would not need to wait for 8 minutes to see our star. the shortest distance between the Earth and the Sun would be a straight line, entering the uncertainty principle. If the Sun went out or died at this moment, nothing would change in the sky. Therefore, when physicists set the 0 point in the position of the Sun, from where the time counting would begin, they are not realizing that, when it comes to the observer's point of view, time would start in its position on Earth, because nothing existed before that, not even the hypothetical death of the star. The continuum, defended in the theory of relativity, would not take into account the hypothetical separation between space and light, as long as the light is retained within the cone of light of the future, or within the cone of any other massive event. What would justify this attitude of science? It is that this event of retention of light in our future cannot be measured directly. Therefore, it does not exist. Science preferred to opt for the hypothesis that the light of the stars was coming from our past, as the past can be assessed, indirectly, by the limited speed of light. The possible misunderstanding would not be mathematical, just a matter of points of view. Note that, if the light were retained, the same would happen with time. This would link the speed of light to time. The light would suggest that it was taking too long, due to the simultaneous retention of time. In fact, time does not exist at that location in space, because it cannot be directly measured. This is predicted in the theory of black holes. If you tried to approach one of them, your time would run out. So, according to Stephen Hawking, the black hole would always be in the observer's future. It is seen that time would be closely linked to the relative and continuous movement, assumed by light only in our past, or after it abandoned the cone of light of the future of the event. This hypothetical separation between light and space would completely change our current cosmological view due to its theoretical developments.